Hi everyone, welcome to this webinar on improving seedling germination and establishment. My name is Tom Morrison and I am the Technical Development Manager for Indigrow. Now my role mainly involves supporting our UK and European sales teams with technical backup, but another facet of my role is to drive the trial and development work on our new and existing product portfolio. So today's presentation will cover some of the independent trial work that we completed last year. And one thing I want to do in my role is supply our end users with practical advice that's backed by trial work that you can implement on your surfaces, whether that be at the golf course or other sports surfaces such as football, rugby, cricket. Now, the presentation will have particular significance to the upcoming spring renovation period, but equally it's relevant to autumn renovations and renovation of football pitches during the close season. I know some of our customer base are out in Scandinavia, and the spring renovation window can be a really critical time for them to get surfaces into a playable condition as quickly as possible following what is usually quite a harsh winter. And whilst I hope those guys that are based in northern parts of Europe, Scandinavia and the like, I hope you haven't got much overseeding to do due to winter kill or disease scarring. Hopefully, what I'm going to cover today will give you a bit of peace of mind that there are tools out there that ensure you get the best possible recovery. So as a bit of an overview of what I'll cover during the presentation, first I want to focus on why good seed germination and establishment are essential for healthy turf and the things that we can get into our surface to help us going forward. We'll look at how different inputs, both granular and liquid, can affect early growth and rooting of the grass plant and seedlings. We'll then move on to the independent trial work that we carried out last year and look at the early establishment phase of those seedlings. And then at the end, we'll hopefully round it up with some practical advice for successful turf renovations that you guys can take forward into your daily roles. So it'll come as no surprise to you that getting good quality surfaces throughout the year is only getting increasingly challenging. We seem to be getting it from all angles these days. But there's three key pressures that I constantly hear during my travels around Europe and UK. And the three that I would select would be withdrawal of active ingredients, so the chemicals that are available to us to use, the unpredictable and more extreme weather that we're seeing more regularly now, and then these two sort of combining to increase the disease pressure that we see on our surfaces. Now, most frustratingly of all for you guys is that these are all out of your control, and you're the guys that have to deal with the direct consequences of that. So just zooming in on chemical withdrawal a little more, it's all quite old hat now to hear it, but we're getting a reduction in the amount of active ingredients that are available to us, and this essentially limits our flexibility and the choices that we have in being preventative and reactive to diseases. Reliance on fewer actives means that we're less flexible. We apply the same chemistries over and over again, and in this case, the diseases can become more resistant to that. So not having as great a amount of preventative options, it can basically leave us in a position where we're seeing greater disease pressure and we're having to be more reactive in our controls, seeing the disease and treating as opposed to preempting that disease. And the name of the game for you guys essentially is maintaining consistent quality turf. And with this pressure from chemical withdrawal and the disease that we see because of that, it becomes more challenging. The next thing that I'd like to point out is the water scarcity. Now, the UK is probably very overly reliant, should I say, on mains water. This is a really expensive and not sustainable method of watering our surfaces. But we're seeing more and more pressure on these sorts of resources, even things like river abstraction, borehole abstraction. It's very likely in the near future, perhaps, that those licenses aren't going to be renewed, and we're going to have to look for different forms of water. So looking into investing in reservoirs on on sites so that you can feed your irrigation. We're coupling this with seeing hotter, drier summers where we're not getting the reliable rainfall, particularly in the UK, south of the UK. We've always had a reliable amount of rainfall. Feels quite funny sat here in the northwest of England at the moment after we come. I can't remember the last time I saw a blue sky, but the reality is we've only just about topped up our soils from the last summer that we had in 2025, where we saw a prolonged drought period. So this pushes us to a heavier reliance on lower quality water, more alternative sources, and all these things combine to increase the amount of stress on the plant. So somewhat linked to the water scarcity, climate change. As you know, the weather is becoming more and more unpredictable. We're seeing the hotter, drier summers that are giving us drought stress on the turf. We're also getting those milder, wetter winters, which are extending those periods of disease stress. So when we get these overlaps, what would typically be the autumn and spring period where we'd usually see these disease stress periods, those 2-degree stopping hours on mycodochium, for example, are much less frequent now. So again, this is really pushing you guys as turf managers into a corner where you're really struggling to maintain these playing surface conditions throughout the year. Now, admittedly, it's all been very negative so far, so please keep listening. There is hope on the horizon. There's a lot of research and investment going into different technologies and tactics when it comes to disease and stress management within turf. Just to name a few, disease modeling is a big thing now, so that you can be more preventative in your applications of different technologies and chemistries. There's better technologies out there. Anyone who attended BTME this year may have seen the sprayer, the robotic sprayer, which can target individual weeds. It's likely that technology will come out in future to do the same with disease as well. And then you'll be no stranger to biostimulants and the amount of research that's now going into there. But I want to sort of focus on the integrated pest management. A friend of mine and any colleagues of mine will know that integrated pest management, and this slide in particular, always feature quite heavily at the start of most of my presentations. So those who aren't familiar with integrated pest management, sometimes it's termed as integrated turf management, integrated disease management. Well, what it is it's a holistic approach to maintaining healthy turf. So using a lot of combined methods, starting from more preventative cultural practices, leading up to the break glass in case of emergency, I often call it, with the chemical at the top. And it's important that we do this because the chemicals, whilst they are there, are extremely important to us. We want to be using the more preventative cultural practices, of course, but when disease pressure is at its highest, we want those chemicals available to us, and we can only use that keep that in place through responsible use. So part of this IPN, ITM, whatever you want to call it, or integrated pest management, one of those parts of the pyramid was cultural line of defence, and overseeding or reseeding our surfaces would be a key part of those cultural practices. Now, modern seed breeding is really developed over the past few years, and in my opinion, it gives us a real thing to hang our hopes on. Modern seed breeding can provide us with genetics within plants that give us more tolerance to drought, heat, all these types of abiotic stresses, but also, on the other hand, can give us more resistance to these turf diseases that we commonly see on our surfaces. And then on top of that, we get better wear tolerance and recovery potential from the characteristics of these newer cultivars. Now, we can only provide these additional benefits through seed breeding technologies if we get these seeds into the ground and successfully established. So a renovation period, whether that be on a golf course or a football pitch or any sort of turf surface, it provides us with that opportunity to get seed into the ground. Now, as a fertilizer supplier, we're somewhat limited in our ability to do this. We can certainly advise on it, but it's more about selecting the seed that's right for your environment. So I wanted to put this sort of flow chart together that sort of details what your thinking process might be to implement a species exchange on your surfaces. So we generally start with the selection of a certain cultivar or a mix. And the conversation you need to have there, whether it be through an Indigrow rep or a seed supplier rep, will be that you need a seed that is specific to your site and relevant to the challenges that you face on your golf course or your stadium or whatever it may be. You know, just as an example, if we're a Parkland golf course in the north of England that has a lot of heavy shade and clay soil, we're probably going to need a different characteristics from our cultivars than, say, a links course that is based down in the southeast of the UK, where drought pressure is going to be higher. Next, it's kind of over to you guys. Once you've selected that, it's all about seedbed prep, making sure that you're getting that seed into a depth with the right machinery or tools that it can germinate successfully. And the all important thing being soil to seed contact. And again, that links back to the machinery or type of overseeding that we select. And then the aftercare. And now, as a fertilizer company, this is where we can get a little bit more involved. Yes, the moisture is somewhat relevant to the weather, but with irrigation systems, we can tailor that. The temperature, we're at the beck and call of the weather, unfortunately, but waiting for a time when seed is best placed to germinate in the ground, soil temperatures up towards 15 degrees would be the best sort of area that we'd be looking at. But we can then get involved with these supportive products. And I knew that within our portfolio, we had products that could support the early stages of development of seedlings, but we wanted to run some trial work that really backed that up. So yeah, onto the trials. And in all honesty, this was kind of motivated by the hot summer that we experienced in the UK last year. But obviously there is relevance to that all around continental Europe. Courses were losing a lot of grass cover because of the extended drought, and they needed to regain this coverage through overseeding with better and giving the opportunity to get better cultivars in there that were better suited to those stresses. But then also looking at how these products could reduce recovery times, whether that be in football, where we have a limited window of sometimes as low as 4 to 5 weeks to get a pitch ready to play on again. And as we know in golf, the players want to get out there. They've been sat waiting on winter greens throughout the winter period, or in some cases, Scandinavia, places like that, where the golf course has been closed for an extended period of time. So the golfers want to get back on the golf course as quickly as possible. And we know that this is very important for the revenue of sites as well. So yeah, we wanted to look at not just the best products, but what could influence and speed up the process to get those surfaces back in the best condition. So I'll cover 3 of the products that we included within those trials. The first of which was Compass composted seaweed. Now this is a granular seaweed. It's made from the meal of seaweed. It has a nitrogen content of 3%, the NPK analysis being 310 with 3% calcium, and then the composted seaweed element. Now there is the nitrogen source is split in half. It's half more there or thereabouts half ammonium, so we get a good cool temperature response from it. But then also half of that being from an organic source, so it releases nutrient over time when soil conditions are right. We knew that this was very successful in turf renovations, both in golf settings and in football settings. And we knew that it had an impact on early seed germination, with, in some cases, people saying that their football pitches, they could get back on them up to 5 to 7 days earlier. So the next product will be Compass Start, and this is our go-to early season liquid seaweed, an NPK analysis of 444. It includes molasses and wetting agent. The molasses are there to help stimulate existing microbial populations within the soil to start upregulating the soil, to start nutrient cycling and making more nutrients available to the plant. The wetting agent, we can quite often see surface sealing after winter where small amounts of compaction have happened from traffic, from machinery and golfers on wet surfaces, and this helps to get the product down into the soil as a penetrant effect. And then lastly, and this was kind of included as a control, if you will, but we wanted it in there as because we knew it was a good product to be using around the time of renovations. But we also wanted to learn when is it best that a pre-seeder is applied. So our go-to pre-seeder would be Impact Plus Emerge, an NPK analysis of 10-20-10. And for those that aren't familiar with pre-seeders, generally what you're looking for on the bag or the label is where you've got the three numbers signaling NPK percentage, that the middle number, or the P, the phosphorus, is higher than the other inputs, the N and the K, the nitrogen and the potassium. Now, typically everybody has sort of gone to a pre-seeder if they are doing some sort of renovation or pre-seeding or turfing, that type of thing. It's just kind of the thing that's always been said and what to do. And that's why we wanted to include it, to see whether we could find anything out about whether there was a better use of it or better timing for the application. Now, with this Impact Plus Emerge, it's heavily weighted towards an ammonium form of nitrogen, so we get able to get that cool temperature response. The nitrogen is available to the plant in lower temperatures. And then, as with all our Impact Plus granular fertilizers, the Asset Gold coating on it, which is a concentrated amino acid, which helps with stress tolerance of the plant. So just to give you an overview of the trial, the whole thing was to assess the early growth, and this was conducted on perennial ryegrass, which is a go-to grass for trial work. It establishes well, it allows you to see the difference between treatments. But as you'll see in some images later in the presentation, we have seen really good response to bent fescue mixes as well. So we used pots in this case with a peat-free, low-nutrient compost. The granular treatments were applied at sowing of the seed, which is important to note. The liquid treatment of the Compass Start was applied once we were at a stage where the plant got to 2 to 3 leaf stage, where we had a leaf to apply something to. So the 444 NPK liquid feed within the Compass Start could potentially be taken up by the leaf itself, as well as through soil application. Now, these were greenhouse grown in great conditions. 20.4 degrees was the average temperature with 61.4, average humidity. So really good growing conditions. And this, coupled with the low nutrient compost, we hope would show that any sort of differences between the treatment would really show up. Needless to say, the pots received adequate watering as and when it was required, and this was all the same across all replicates, 6 replicates of each, so that we had a good basis for averages, that kind of thing. Important to note that this was carried out by an independent trial facility, as I mentioned at the start of the presentation. We conduct in-house trials. We rely a lot on user feedback, which is extremely valuable to us. But getting those independent results is brilliant for us because it means we're a bit hands-off in it. Yes, we might design the trial for something that we're looking at, but independent results that are assessed without our involvement is the best form of feedback when it goes well, of course. And we ran this over a duration of 25 days. As I mentioned earlier, this was all about getting surface back into play as quickly as possible, and we felt that this sort of just shy of a month period was really relevant to those football settings where you've got a 4 to 5, 6 week turnaround, but also in a golf setting where you want to get those surfaces back in play as soon as possible. So there's minimal disruption to the surface, the playability of the surface, and the recovery and looks of the surface. Now, trial treatment. So I really want to point a few things out here. So I'll select my pointer. You can see here the three different treatments that we selected: the Impact Plus Emerge, the pre-seeder granular, the composted seaweed granular, and then the Compass Start, the liquid seaweed. We did all three treatments at two different rates, so a low rate and a high rate. And then, as you can see, the timing of the applications I've already mentioned. The granular applications were made at the exact same time that the pots were seeded. The Compass Start, however, it just so happened that 12 days after seeding, we got to a 2 to 3 leaf growth stage within the plant, and that was when we were going to apply the Compass Start. Now you can see that it was done at 10 and 20 litres per hectare, a low and a high rate, just as the granular treatments were done. One thing to pick out of this, if we ignore everything else for just for a moment, is the nitrogen inputs here. So with a granular pre-seeder, such as the Impact Plus Emerge, this is a 10-20-10 analysis, as I mentioned. When we're applying that 40 grams per square metre, which is a high rate, we're applying at 40 kilos of nitrogen per hectare, which can make up a large part of somebody's input for the entire year. You know, if you're on a low input fescue surface, that might be over 50% or more of your overall annual nitrogen inputs. So it's a significant amount, and we'd expect to see a significant benefit to that. Composted seaweed being a 3-1-0 analysis, you can see it's lower yet. And then the Compass Start being a liquid applied at lower rates and at less expense, should I mention, is that 0.5 and 1 kilo per hectare were applied. So a significantly amount less nitrogen. And you'll see some of the most interesting results based on that later in the presentation. So we know what the objective of the trial was, but what were we measuring so that we could, tick off that we'd achieve those objectives? So we were looking at germination in the first instance. That was the most important thing to us. And this indicates the success. How much value have you got out of that bag of seed? What percentage and how quickly is that seed germinated? We then looked at plant height, which is really important in assessing how much nutrient the plant is taking up and how efficient that plant is being at growing. We then would be collecting data on fresh weight, so essentially harvesting the grass after anything above ground after the trial had concluded. And this, if we think of it in a human sense, would be our whole body. It's our skeleton, it's our blood, it's all the moisture and everything that's within us. And that's quite important for assessing overall growth. And then finally, the dry weight. Now this, if we go back to the human sense, would just be the skeleton. So it's looking at how much organic matter is produced, what's the lignin and the skeleton of that plant. And it would indicate sort of true growth efficiency. Are we getting a plant that is just very lush and leggy, or are we getting a robust plant that can tolerate after or establish and continue long after the establishment period? So getting on to the results now, this focuses on the germination count. Now, I'll just remind you that the Compass Start treatments weren't included at this point. As I said, we wanted to wait for the leaf to emerge to apply the liquid to, but we saw some really stark contrasts here. The composted seaweed granular, which is indicated by the two sort of orangey coloured lines at the top here, and the grey being the control, so received no treatment, just the seeding, and then the green lines was the pre-seeder, the 10-20-10 Impact Plus Emerge. Most interestingly, what we can see is that the pre-seeder, which has always traditionally been something that you would put down at the time of seeding, actually, in terms of germination after 5 days, performed worse than a control. at both rates. But this does make sense. When you think of a seed, you put the seed down, you do whatever other operations, whether that be top dressing and brushing in afterwards, and then you put a granular down, you put the sprinklers on, and you wait for things to happen. Now, at that point, the seed doesn't have a root, and we know that nutrients need to be in solution for the plant to take up, unless we're applying them to a leaf, and a seed doesn't have a leaf, much like it doesn't have a root. So it stands to reason that whilst we're looking after those seeds on the ground, we're trying to keep them moist, we're applying irrigation, watering, all those sorts of things, we're going to be washing nutrient through the profile at this point, to a point where it will leach through the surface and not be available to the plant. We're losing value for money out of that application. Now, yes, it did pick up after time and was better than the control after 8 days. But what I really want to point out here is the composted seaweed and its performance here. Now, interestingly enough, after 5 days, the lower rate, the lighter coloured yellow line that you can see here, actually performed better than 75 grams per square metre. And once we accelerate past to the 8-day period, we can see that there's not really a great deal of difference between those two treatments. Now, this is really important for me as a technical manager going out there advising customers. Salesmen perhaps won't agree with me, but we can advise our customers to use less product in this case, which is not only better for sustainability, but it's better for budgets. And what we surmise why this has had such a greater beneficial response compared to the control or the Impact Plus Emerge is that the seaweed is perhaps having a biostimulant-like effect on the seed in its early stages, forcing it to germinate quicker or triggering it to germinate quicker. But also with the organic matter that's within that granular, it may be that it's holding more moisture closer to the roots or something like that. Those are the sort of assumptions that we make based on that. So yeah, in summary of that slide, basically a low rate of this granular seaweed is up to 124% increase on average in germination after 5 days. So quite a staggering amount, really. And even after 8 days, we see up to a 59% increase on any other treatment. So yeah, really helping to get the best out of and the value out of that bag of seed that you've oversown with. Now, looking at average plant height, so as we mentioned, this is about assessing the early growth of the plant. How efficient is it being in taking up nutrient and being able to grow? I mentioned that 12 days after seeding that we had a leaf that we could apply to on the Compass Start treatments. Important to mention that they received no other treatment prior, whereas the other plots had a granular applied at time of seeding. This one waited until the leaf emerged. So what you can see from this graph, where the red line is this is where the Compass Start was applied. And most importantly, and quite good for us, is that all treatments were better than the control, which we always like to see. Now, focus on the pink lines, the dark and the light, signifying the low and the high rate of Compass Start. What we can see is when it's applied here, we see this short delay, and then it accelerates past all other treatments. Now, this is really impressive because at this point it's received no other input. So what we're seeing here is that once applied, it has a really good effect on that. So if we put this last slide where we saw the germination together with this one, what we're suggesting based on this is that you wait for the germination and hopefully see much more increased, up to 124% in these trials through the use of the granular seaweed. And then once you have a leaf emerge, that you apply the Compass Start to really accelerate that growth. Now, this is looking at a overall average of all the shoot fresh weights. So as I said, what we do at this point, at the conclusion of the trial, is all above ground biomass, is harvested, it's cut off, it's weighed, and the fresh weight is as is, with all moisture within the leaf, water within the leaf. What we can see here is that if we just discount the statistical analysis, which I'll talk about in a minute, we can see that the dark green bar, or the impact plus emerge at a high rate, so the highest amount of nitrogen, that was 40 kilograms per hectare equivalent of nitrogen, is visually on the graph the highest, which is what we would expect to see with that amount of nitrogen. However, when we look at the statistical analysis, and for those that aren't familiar with it, where we've got an A and a B, that means they're statistically significant from one another. So if one's higher than the other, then it means it's better or performed better. So let's focus on the A in the control, the B here for the impact plus emerge at a high rate, the B here for the compass, both the compass start treatments. So all these Bs are not statistically significant from one another, meaning that they essentially have had the same effect to a degree on the grass plant. Now, when we consider this dark green bar, we've seen that this has been achieved at 40 kilos of nitrogen per hectare, so we would kind of expect to see this. However, the compass start treatments achieve this at 0.5 and 1%, 1 kilo of nitrogen per hectare. So they're having a really good effect on that with much less input of nitrogen. And also the fact that that application of nitrogen through the granulars come at a significantly higher cost than just 10 or 20 litres of a liquid seaweed. So yeah, really good to see that. Now, it's one thing looking at graphs. I'm used to looking at graphs, and I was a greenkeeper myself. And back then, you're a practical person. You want to see things visually, that kind of thing. So I always try and provide that within my presentations. So I've picked out those 3 treatments that were statistically the same as each other: the impact plus emerge at the high rate, and then both the compass start treatments. And I've noted here, just as a reminder, the inputs of nitrogen. Now, it's down to opinion here, but yes, I think this one looks the most lush. It's perhaps just a shade greener than the other 2 treatments. But when we consider that extra cost and the extra amount of nitrogen that's been applied there, plus some wastage from that nitrogen in the early stages before we saw germination, it's fair to say that these are being much more efficient. So yeah, hopefully you can take something from that. The 3 pots on the left of these are the control, just as a comparison, so they receive no treatment. And then as regards to total shoot fresh weight, this shows a similar average similar trend to the averages that we saw before, but I wanted to include it as a comparison to the dry weight afterwards. And if you focus on the difference between these bars and the next slide. So as I said, it followed a similar trend to shoot fresh weight, and this is the total. So this the total amount of shoots that were harvested at the end of the trial on the last slide, and then weighed in. This is the total shoot dry weight. So once it's placed into an oven and dried out and all moisture is removed, it's weighed again. So we're measuring the real skeleton of the plant, if you will. Now, it followed a very similar trend to the fresh weight. However, the 20 litres per hectare rate of the compass start here resulted in a lower dry weight, than the 10 litre per hectare rate of treatment. And this suggests that basically the 20 litre per hectare application led to a greater amount of water within the plant. Now, we could argue that that is creating lush growth that's perhaps more susceptible to disease. But in this early stage of the plant developing and getting it established, we can sometimes see those dry springs where the plant gets drought stressed, even in cooler temperatures. So that would tend to say, or would lean towards saying, that the plant could potentially be more drought tolerant. I'll let you make your mind up on that, whether it's positive or negative. Now, moving on to root development, we didn't actually do some formal assessment of the roots in this one, but we wanted to just gather some photos. I appreciate it's probably quite difficult to see the differences between here, but as I said, we didn't do any real analysis of that. We have got a lot of data already for our seaweed applications in particular and their effect on root stimulation and development. But what I've done on this next slide is just zoom in on a couple that were visually more impressive, and these were assessed sort of blind. Someone who wasn't involved in the trial, can you pick out what you would see as the worst root mass versus the best? So not the most scientifically thing, but as I said, we've done prior studies on our seaweed extracts and their effects on root analysis, and this gives us something that we can look at in future as well. So what was picked in the blind test was the compass start at 20 litres per hectare. We can see there that we've perhaps got more finer roots, maybe. Again, I'll leave this up to your interpretation. Whilst in the untreated, we've got some good roots there. It's perhaps a bit more dense and there's more root hairs there in the compass start treatment. So as I said before, giving you something visual, we can look at graphs all day and statistical analysis, but as practical people that are working on surfaces, I want to give you something, a diagnostic, or something you can take away and easily implement on your site. So if your objective in the left-hand column here, you can select from that, is to maximize germination, then what we've seen that the composted seaweed at either rate, it's arguable that bang for your buck, you want to go with the lower rate at 35 grams per square metre. Why would you do that? Well, we saw significantly more seedlings emerge, over 100% more seedlings emerged in those first 5 days using the compass composted seaweed. If you're then wanting to push the early development, so you've got that seed out of the ground with the composted seaweed, then the compass start, once the leaf emerges, has proven to be a great addition. We had the tallest plants there after foliar application, so showing that we're really pushing the development of that plant and the growth of that plant. If you want to boost the overall biomass, then using lots of nitrogen, strangely enough, worked. So the Impact Plus emerge at the high rate. We got a significant fresh weight gain from that. And then arguably based on the difference between the fresh weight and the dry weight, the 20 litres per hectare application of Compass Start, we saw a better or a higher fresh dry weight ratio, which indicates more water retention within the plant, so it could see it through a dry period in spring, perhaps a bit better than another treatment. And then if you want to look at strengthening the root system, then any Compass Start application above 10 litres, the 20 litres was picked in a blind test, and that is shown to show the greatest root development. So yeah, just in conclusion, and to just really drive it home, and it can seem quite a lot when you're looking at graphs and different things and different products. But what we can see is that the use of seaweed products can generate not only improved germination and accelerate establishment, but it can do that with lower nutrient inputs. So not using these high amounts of nitrogen that typically have been used in the past for establishment. So if you find yourself in a position this spring where you're looking for that rapid seedling establishment, our recommendation based off the back of this trial will be to use Compass composted seaweed. This is a powerful tool in getting seeds out of the ground, which when you're paying quite large quantities of money for seed these days, it's important that you get value for money out of those bags of seed. Once you've got that leaf and you got that seed out of the ground, the Compass Start has proven that it gave really good boost to young seedlings and really improved that root development in the early stages. And then this is where the timing of application of a pre-seeder has perhaps been found out. Rather than putting something down at the time of seeding, perhaps we're best waiting until we've, used the composted seaweed to get the seed out of the ground. We've then pushed that further on using the compass start, and then perhaps it's time for an application of our Impact Plus Emerge. If we do that, then we're not suffering from this loss of nutrient percentage through watering of the surface prior to that grass plant having a root where it can access the solubilized nutrients from the granular. So yeah, that's proven to really push biomass. So I would say it's best to probably delay your application of a granular pre-seeder like this until you see that plant emerge and it's starting to develop a root system. It could then really push it on and put some biomass into that surface following that. So yeah, again, it's all well and good looking at graphs and my recommendations and things like that, but these are some images that we received from a customer who'd used the composted seaweed following a renovation. And I think they kind of speak for themselves, really. There's not really much I can say that would improve the way those photos look. But yeah, some really impressive results there, really getting a good strike from those seeds in the early stages. Yes, they need nursing through after that. There's a difference between germination and establishment. The hardest part is establishment and keeping those there. But this has really proven to give you that good footing and good foundation to build on to get these better genetics from these cultivars into your surface. And then just to give you a sort of flow chart of how our customers have typically implemented the composted seaweed and the compass start. So what they tend to do is they aerate and they seed and they top dress in whatever order they usually do. They then apply the composted seaweed and then generally would brush this into the holes. It does great work if it's within the surface, providing that nutrient over time. Obviously, you'll end up with some on the surface, but with it being a slightly larger prill size, it's best in the early season to get this into the holes in the ground around the surface. We then hopefully see, like we did in the trial, improved germination success. And then once we've got those seedlings emerging, like in the last photo, we can apply the compass start, and that really pushes it on. As one of our customers said, it's like Red Bull for grass. And then hopefully we end up in a position where we've maximised our establishment and recovery. So yeah, obviously you can't ask me any questions at the moment, but my contact details are up on screen there. You can contact us through the Indigrow website where they'll put you in touch with your local sales rep. I'd be more than happy to field any questions over email. And thank you very much for your time and attention watching this. Look out for more webinars in future. We will be running them. And yeah, thank you from me. Bye-bye.